to us a little bit about network slicing and network customization, and please submit questions throughout the presentation. We'll get to those as time allows.
Thanks, Sean. Welcome, everybody. So what I want to cover in the next, I guess, 10-15 minutes is really talk about extreme automation for 5G slicing. And this title should be kind of reworded. I guess extreme automation is required for 5G slicing to kind of even be possible. But before we get into the kind of meat of what I mean by extreme automation, I want to explain why kind of 5G and 5G slicing is important and interesting to IBM, which will kind of explain or set the scene for the automation story we tell later on. But firstly, of course, kind of 5G is built on cloud native principles itself. So it's a software-based solution with kind of software cloud native principles, but it runs on traditional or nearly traditional data center like hardware. So we have software running as virtual machines or containers on x86 based servers that look and feel like a data center. With traditional operating systems and that kind of stuff. So this means on the IBM side, all of the tools and learnings that we have from managing this kind of infrastructure and software running on this infrastructure at scale, from our experiences in public cloud, but also all the kind of hybrid cloud tooling and methodologies and best practice that we have can be brought to bear to help service providers build out these kind of data center, telco based kind of data centers at scale. So these tools, methodologies for achieving kind of hyperscale operational automation are applicable to this environment with extensions, to kind of make them or tune them to be particular to kind of networking and network workloads. And that's what we'll talk about in a second. But as importantly and kind of almost as exciting is 5G is open in that you can break traffic out of the cellular network and route it to IT applications that run on the same infrastructure as the kind of 5G network functions themselves. So because everything is x86 based or kind of racked and stacked servers in a traditional cloud sense, IT applications can run on the same infrastructure. But as I said, as importantly, we can route or break traffic out of the 5G network a lot easier than any of the previous kind of generations of cellular networks. So we can route traffic to the internet directly from the edge or to IT applications that live across the edge, and that kind of brings with it a whole bunch of kind of really exciting opportunities for telcos to take advantage of kind of these new workloads and so on, but also for our enterprise customers who can achieve low latency, high performance kind of use cases by putting analytics or control systems at the edge with a high bandwidth, low latency connection to, we've seen some really cool use cases around drones or, cars are the kind of obvious one, or private 5G inside manufacturing plants to replace fiber and so on. So the vision is that, these enterprise customers can order their own slices, even order that they want to deploy IT applications into a network, and change that over time as they see fit. So it's a very dynamic kind of vision for how, at least from our point of view, how enterprises can engage with their own slice, their own requirements, and so on. So this is kind of funky move, but that was kind of a very happy path point of view. So it was, the vision, the kind of, I can order my own slice when and where I want and manage it independently as an end customer, right? So again, a happy kind of path. But so as I mentioned, we've got a cloud native environment which effectively has disaggregated absolutely everything. The software that run on various servers with different smart NICs and all of the networking between all the different piece parts. So absolutely every piece part of the stack that delivers those 5G slices has been disaggregated, so it can be procured separately. I can buy hardware independently. I can buy accelerator cards independently. I can, and so on. I can buy software that runs on the servers and the software that the 5G kind of core and radio software independently. But then I need to assemble all of that set of piece parts. So from a procurement point of view, that's really good. From an innovation point of view, that's really good. So I can buy the best widget, the best radio controller for managing beams for drones, or the best smart NIC card that can run analog to digital kind of signal processing, or whatever makes sense. So there's innovation in procurement scale and so on. But at the end of the day, somebody's got to assemble all of these piece parts on a pretty massive scale into whatever those enterprise customers have ultimately ordered as a piece of wireless connectivity across a set of regions, right? So this picture is trying to articulate the complexity of the various moving parts that need to be assembled, vertically and horizontally. If you look at the top of this picture, which is kind of the IT or the enterprise customer's view of how they would engage with a 5G service provider. So the top of this picture is the level of complexity that the customer would only want to see. So I need connectivity from these geos of a certain QoS and uplink and downlink, and potentially I might want to deploy my own applications at the edge and that kind of stuff. And that then would cause a decomposition of, what network functions are required to be assembled in what fashion to deliver that performance, but also to break traffic out at the right locations. So there's a decomposition of what the customers ordered into a set of network functions that are assembled across those sites. And underneath, you can see that all of those functions have, networking requirements that needs to be married with the performance that the customer expects. And at the very bottom, you have physical sites that ultimately run the virtual machines and containers and execute that the kind of fabric and interconnected networking that's required, right? So there's a hefty decomposition of how you get from what the customer's ordered into a whole series of moving parts, and it doesn't stop there. The customer can make planned changes, so the customer can add sites or increase its uplink or connectivity requirements between existing sites. So there are planned changes at the top that are required to ripple through all of the layers underneath. And of course, there are unplanned changes. So things go wrong, like software malfunctions or hardware malfunctions, or I need to do an upgrade of any of the piece parts in this picture to continually deliver the service that the customer has required, right? And all of these layers are kind of horizontally. There are sets of relationships that need to be managed across network applications, but vertically, very kind of clear dependencies between what hardware runs what software and so on, right? So this picture, if you like, is continually needs to be updated and optimized and healed if something goes wrong and all that kind of stuff. So that's everything I'm talking about would normally be packaged up in a complete solution from a traditional network equipment provider, but now this kind of massive disaggregation means something else needs to perform that role of assembling all of these piece parts. But there's an opportunity as well to inject intelligence that can figure out how to best organize this kind of multidimensional graph to deliver more performance or cost efficiency. So how can I run this hotter, or how can I reorganize the various layers to deliver more performance, or whatever is required. So this is kind of the complexity picture or a problem statement, I guess, for what needs to be automated and automated in a more intelligent fashion on an ongoing basis. Of course, let me build this slide. As well as the complexity in the disaggregated graph that we saw, right, or multidimensional set of topologies, Telco is, and even though I said that everything is kind of based on cloud native principles and traditional, in quotes, infrastructure, telco is as ever special. And what I mean by this is, VNFs or CNFs, networking software has some very, very hard dependencies on the stack underneath. So hardware dependencies like, we've seen dependencies where we need a particular motherboard configuration, or software won't run, or specific hardware with firmware and BIOS settings and operating system tuning parameters, or smart NICs, FPGA cards, and the list goes on, right? So every piece of networking software that we've encountered so far has not just, it's not just accelerated, but has high degrees of acceleration required to achieve packet processing or digital signal kind of processing, or whatever that accelerator needs to do, right? So what this means is placement of these containers and virtual machines is really deterministic, and it gets more and more deterministic as you move towards the edge of the network. So I need to prepare a server, from a tuning point of view, a BIOS setting point of view, all that stuff we talked about. I need to prepare a server for it to receive a particular network function. So I need to know exactly where something is going to go, and even kind of worse than that, I need to very much in the core of the network need to co-locate software processes on the same NUMA node, for example. So on the same core with a shared memory bus to achieve, high packet processing and things like that. So this is exactly the opposite to cloud native principles in that, in a cloud placement of where you run containers and virtual machines is absolutely non-deterministic. So it's wherever makes sense. Here it's very much, I'm preparing these servers for a particular workload, and if I want to repurpose a server to run a different workload, there's quite a tuning process that needs to be kicked off and automated to make that happen. And so that's kind of south of the VNFs and CNFs, and north of those are, at an application level, network application level, there are many kind of interdependencies that need to be managed horizontally. Which leads us on to IBM's Cloud Pak for Network Automation. This is an offering that builds on IBM's heritage of managing hybrid clouds and taking a kind of cloud native approach to full stack automation, and applying it to the networks of now and tomorrow. So if you look at the center of our universe is this kind of disaggregated stack that we just talked about. Red Hat's at the center of our universe, as you can imagine. Underneath Red Hat is a whole hardware ecosystem. Above it, a network software ecosystem. And on the left-hand side are the use cases that we are performing around that set of ecosystems for 5G, and not just 5G, but for networking in general. But so we have a set of tools that are very much following the model, a desired state of everything up and down the stack that you see in the middle of this picture. So we have tools that can model data center inventory, model how CNFs or VNFs are dependent on the infrastructure in that data center, and then also slice together those network applications into network services, and ultimately a set of rules that allow us to figure out slice placement and slice binding rules and that kind of stuff. So we have modeling tools that allow us to capture the intended design for one of the vertical, turnkey solutions you see up and down this ecosystem in the picture in front of you. And then, very similar to Kubernetes and those types of technologies, we intent that end-to-end design into an operational state, and our system figures out, all of the sequencing that needs to happen to make that work. But as importantly, as changes, unplanned or planned changes need to happen, we basically we can draw a new version of that complete set of topologies, and again make the system bring it all into a state of active. So in this way, our goal in IBM is to bring the same kind of hyperscale levels of automation that you can see in public cloud-like environments and apply it to this disaggregated world, so that the experience for a telco and the experience for a telco's customers, all those kind of enterprises that we talked about, very much mimics the experience you get in a public cloud. So zero touch automation of all of the piece parts in a particular design for an end customer. And Sean, I think that's it. Hopefully I didn't overrun.
No, that was great. I really appreciate the informative presentation, Brian. And for our audience, you can hop over into a concurrent session. I believe Tarek Amin is giving a keynote, and then we're going to take a break. And then be sure to make plans for the roundtable sessions this afternoon. But Brian, thank you again for keeping us up to date with what IBM is doing to support this move to telco cloud.
Thank you.